Hello, in this video, we will learn what are K-maps and how to use them to minimize SOP and POS expressions. Now in our previous video, we have learned Boolean laws and how to use them to simplify expressions. It is, however, a time-consuming step-by-step process. To overcome this difficulty, Karnaugh or K-map were introduced. It is a graphical or matrix method of simplification of Boolean expression using visual pattern recognition. It was introduced by Maurice Karnaugh. Now K-map can be applied to reduce any canonical SOP or POS form expression only. So if you do not know canonical SOP and POS form or meaning of min term and max term, you need to watch my video on it first. To summarize, canonical SOP is defined as sum of min terms and canonical POS form is defined as product of max terms. Min term is nothing but product of all input terms either with complement or without complement, while max term is sum of all input terms either with complement or without complement. Canonical SOP can be written in any of these forms and canonical POS can be written in any of these forms. Now typically the question on simplification of K-map will look something like this. Either a complete canonical expression will be given and you would be asked to simplify it, or you could be given a Boolean function as shorter min term or max term expression and you would be asked to simplify it. Or a truth table could be given to you and you have to simplify it using K-maps. Now we will learn how to answer them. First thing is, when you are given the question, you have to check if it is in canonical SOP form or POS form, as K-map for these are different. Now we will solve it in two stages. First stage is where we will learn how to draw a K-map for SOP and POS, and second stage is to actually fill the K-map and follow the rules to simplify the equation. Let's start with stage 1, where we will learn how to draw a K-map. If you know your truth table for SOP and POS, it will be a lot easier for you as K-map is nothing but a rearranged truth table. The first step in stage 1 is to see if the function in your question has 2 variable, 3 variable or 4 variable. Based upon that, K-map will have 2 raised to the power of number of variables of squares. Let's draw a 2 variable K-map first. If we have 2 variables, it will have 2 raised to the power of 2 means 4 squares. We will start with the SOP form. Let's take 2 variables A and B. We will represent A in y-axis and B in x-axis. Now A has 2 possible values 0 and 1 and B also has 2 possible values 0 and 1. Now in SOP form, 0 is represented as A bar and 1 is represented as A. So we write that too in the K-map. Now we write in the K-map all possible combination of values of A and B. When both A and B are 0, we get A bar B bar in the first square. When A is 0 and B is 1, we get A bar B in the second square. When A is 1 and B is 0, we get A B bar, and when both are 1, we get A B. Now we can convert these to their corresponding min terms too. If you know binary to decimal conversion, you know these stands for decimal number 0 to 3 and we denote them with small m for min term. Similarly, now we will learn how to draw 2 variable K-map for POS form. We take 2 variables A and B. We will represent A in y-axis and B in x-axis. Now A has 2 possible values 0 and 1 and B has 2 possible values 0 and 1. Now in POS form, 0 is represented as A and 1 is represented as A bar. So we write that too in the K-map. Now we will write in the K-map all possible combination of values of A and B. When both A and B are 0, we get A plus B in the first square. When A is 0 and B is 1, we get A plus B bar in the second square. When A is 1 and B is 0, we get A bar plus B, and when both are 1, we get A bar plus B bar. Now we can convert these to their corresponding max terms too. If you know binary to decimal conversion, you will know these stand for decimal number 1 to 3, and we denote them with big M for max term. You need to remember and draw this K-map if you get any two-term min or max term expression before you proceed to solve it. Next, we will learn how to draw a 3-variable K-map. If we have 3 variables, it will have 2 raised to the power of 3 means 8 squares. We will start with the SOP form. Let's take 3 variables A, B and C. We will represent A in y-axis and B, C in x-axis. Now A has 2 possible values 0 and 1. B, C have 4 possible values 0, 0, 0, 1, 1, 1 and 1, 0. If you see carefully, we are not writing them in binary progression as you see in the truth table. Instead, they differ by only one place when moving from left to right. 0, 0, 0, 1, 1, 1 and then 1, 0. This binary code is called as gray code, where each successive term differs only in one place. You need to remember this sequence as your K-map will not be correct if you jumble this up. Now in SOP, 0 is represented as A bar and 1 is represented as A. So we write that too in the K-map. We write in the K-map all possible combination of values of A, B and C. When all A, B and C are 0, we get A bar, B bar, C bar in the first square. When A is 0 and B, C are 0, 1, we get A bar, B bar, C in the second square. When A is 0 and B, C are 1, 1, we get A bar, B, C in the third square. When A is 0 and B, C are 1, 0, we get A bar, B, C bar in the fourth square. Similarly, when A is 1 and B, C is 0, 0, we get A, B bar, C bar in fifth square. When A is 1 and B, C is 0, 1, we get A, B bar, C in sixth square, and then A, B, C and A, B, C bar respectively. Now we can convert these to their corresponding minterms by doing binary to decimal conversion. And these stands for decimal number 0, 1, 3, 2 and 4, 5, 7 and 6. Now remember this sequence for 3 variable K-map and note that this is happening because we are using gray code. 3 is coming before 2 in the first row and 7 is coming before 6 in the second row. Now we will learn how to draw 3 variable K-map for POS form. We will take 3 variables A, B and C. We will represent A in y-axis and B and C in x-axis. Now A has 2 possible values 0 and 1 and B and C has 4 possible values 0, 0, 0, 1, 1, 1 and 1, 0. Note here also they are written in gray code and each successive number differs in only one place. Now in POS, 0 is represented as A and 1 is represented as A bar. So we write that too for A, B and C in the K-map. Now we write in the K-map all possible combination of values of A, B and C. When all A, B, C are 0, we get A plus B plus C in the first square. When A and B are 0 and C is 1, we get A plus B plus C bar in the second square. Similarly, we'll get a plus b bar plus c bar in the third square and a plus b bar plus c in the fourth square. In next row, when a is 1 and bc is 0, 0, we get a bar plus b plus c, and when a is 1 and bc is 0, 1, and we get a bar plus b plus c bar and a bar plus b bar plus c bar and a bar plus b bar plus c in the remaining squares. Now we can convert these to their corresponding max terms by doing binary to decimal conversion. If you see, these numbers are same as min terms 0, 1, 3, 2 and then 4, 5, 7, 6 because we have used the grey code. You need to remember this sequence and remember that the last two columns are swapped. This is the standard K-map you need to remember and draw if you get any 3-term, min-term or max-term expression before you proceed to solve it. Next, we will draw a 4-variable K-map. If we have 4 variables, it will have 2 raised to the power of 4 means 16 squares. We will start with the SOP form. Let's take 4 variables a, b, c and d. We will represent AB in y-axis and CD in x-axis. Now AB have 4 possible values 0, 0, 0, 1, 1, 1 and 1, 0, and CD too also have similar 4 possible values. Here also they follow the grey code where each successive number differs only in one place. Now in SOP, 0 is represented as A bar and 1 is represented as A. So we write that too for ABCD in K-map. Now we fill in the K-map with all possible combination of values of A, B, C and D like we had done for 2-term and 3-term expression. For example, when all A, B, C, D are 0, we get A bar, B bar, C bar, D bar in first square. When A, B is 0, 0 and C, D are 0, 1, we get A bar, B bar, C bar, D in the second square. Similarly, we fill up all the squares. Now we can convert these to their corresponding min terms by doing binary to decimal conversion. Here you will see a very interesting feature. The first 2 rows are the same as for 3-term K-map and you will see decimal numbers 0, 1, 3, 2, 4, 5, 7, 6 where the last 2 columns are swapped. But here you will see the last 2 rows are swapped exactly like columns because we are using grey code. Next row is 12, 13, 15, 14 and then comes 8, 9, 11 and 10. Similarly, now we will draw 4 variable K-map for POS form. We will take 4 variables A, B, C and D. We will represent AB in y-axis and CD in x-axis. Now AB have 4 possible values 0, 0, 0, 1, 1, 1 and 1, 0 and CD have 4 possible values 0, 0, 0, 1, 1, 1 and 1, 0. Note here also they are written in grey code. Now in POS, 0 is represented as A and 1 is represented as A bar. So we write that too for A, B, C and D in the K-map. Now we fill in the K-map all possible combination of values for A, B and C, D. When all A, B, C, D are 0, we get A plus B plus C plus D in first square. When A, B is 0 and C, D is 0, 1, we get A plus B plus C plus D bar in the second square. Similarly, we fill up all the squares to get all combination of values. Now we can do binary to decimal conversion to convert these to their corresponding max terms numbers. You will see numbers are similar to min terms where last 2 rows and column numbers are swapped due to grey code. You need to remember and draw this standard K-map if you get any 4-term min or max term expression. And to summarize what we have done till now is that we have learned how to create basic template of K-map, which is to be used for both SOP and POS form for 2-term, 3-term and 4-term variable. Take a screenshot of this and remember and draw this correctly, because if you do any errors in this, you will get wrong answer. Now we will move to stage 2, where we will fill up this K-map based upon the expression in the question and simplify it. Now I will explain the simplification rules. We will start with SOP first. The question given to you could have the complete canonical SOP form like f is equal to ab bar plus ab, or you could be given the min term expression of it. Here you will start by taking the 2 variable K-map for SOP, which we had learned to draw earlier. First step is to mark 1 in squares for each product term which is there in your question. Here we will mark M2 and M3 block and remaining as 0. Similarly, your question could be 3-term simplification, like minimize this equation. Here you will take 3 variable K-map for SOP, which we had drawn earlier. We will do the first step and put 1 in squares which are for the terms in our expression. So these 5 will be 1 and remaining will be 0. Your question could be a 4-term expression, like using K-maps, simplify this equation. The first step is the same. We put 1 in squares which have these min term and remaining we will put 0. Once we have finished putting 1 in the squares based upon your question, we do step 2, which is to find adjacent ones to mark octets, quads and pairs. I will use this 4 variable K-map to explain. If 2 adjacent ones are encircled, then it makes a pair. If 4 adjacent ones are encircled, then it makes a quad. And if 8 adjacent ones are circled, then it makes an octet. Note, adjacent is very important. You cannot try to make a chord with spaces in between. Now these groups can overlap. Let's say we have this K-map here. I can make an overlapping group, or it is same as saying that the same one can be encircled more than once. Another important property of K-map is map rolling, which means that its left edges are connected to right edges and top edges are connected to bottom edges. Like for an example in word map. So in this K-map, you can roll over and create chord like this too. To give another example, suppose if your K-map was like this, you can create a chord connecting all the 4 corners or create a pair across like this. When you are making groups, first find the biggest one, which is the octet, and mark them. Then find the chord and then pairs. This is because a bigger group removes more variables. So here we can actually create a chord instead of pair. When you are marking, one thing you need to ensure is that you do not mark redundant groups. Like for example here. Here these ones are already marked in chord, so you do not need to create another group. For simpler expression, the redundant groups need to be kept to minimum. Also, there should not be any number which is not marked. So if there is a number which is not adjacent to any other one, you can individually circle it. Means it cannot be reduced. Once you have finished with identifying the groups, next step is to write the reduced expression for all groups and sum them. Let's learn how to do it. If there is no group and it is individually circled, then it cannot be reduced and you just copy it as is. If you see this chord, here A and D are changing state, means it has both A and A bar and D bar. So we remove them and keep only B bar C. In this chord, A and C are changing state, so we remove them and keep only B bar D bar. Then we just sum them to get our answer. This is our simplified expression which we have got from K-map. Let's go back and complete our previous question. In this two variable question, we have filled the ones and we can identify a pair. Here we can eliminate B bar which is changing state, so this expression can be simplified to only A. And this is our answer. Now let's look at the next three variable question. Here we have filled the ones and we have identified a chord and a pair. We first take the chord. Here we can eliminate A and C which are changing state and take only B in the answer. From the pair we can eliminate B as it is changing state and take A bar C bar in the answer. Now we just sum them and this is our reduced expression and our final answer. Now let's solve our four variable question. Here we have filled ones and we can identify one octet and two chords. We take the octet first. Here we eliminate A, B and D as all three are changing state and just retain C. Next, from this chord we can eliminate C and B, so A bar D is written in the answer. From this chord we can eliminate B and C and A D bar is written in the answer. Now we just sum them up to get our reduced expression. Now we will learn how to do simplification for POS or product of sum. Here also in the question you could be given the complete canonical POS form or you could be given max term expressions. Here we will start by taking the two variable K-map for POS which we had drawn earlier. First step is to mark 0 in squares for each sum term. Here we will put 0 in M0 and M2 block and remaining we will put 1. Next we will encircle adjacent octets, chords or pairs of 0. Note here we are encircling zeros and not ones as in SOP. The grouping rules are however same as SOP. We identify the biggest group first, that is octet, then chord and then pairs. Groups can overlap and we can remove redundant groups. Here we can identify a pair. In next step, we remove the variable which is changing state, like here it is A bar, so the reduced expression is B and that is our answer. Let's take another example for three variable POS expression. Here you will again start by taking three variable K-map for POS which we had learned to draw earlier. First step is to mark zeros in squares for each sum term, remaining are marked 1. Next we find and encircle adjacent octet, chords or pairs of 0. We find two chords here and we mark them. Next we remove the variables which are changing state. In this chord, A and C are changing state, so we take B in the answer. In next chord, A and B are changing state, so we take C bar in the answer. Then we write the reduced expression as product of these terms. This is our final answer. Let's take another example for 4 variable POS expression. Here you will start by taking the 4 variable K-map for POS which we had drawn earlier. First step is to mark 0 in squares for each sum term, remaining are marked 1. Next we find and encircle adjacent octets, chords or pairs of zeros. We find one octet and one chord and we mark them. Next we remove the variable which is changing state, like here we have A, C and D which are changing state, so we take B as the answer. In next chord, B and D are changing state, So we take sum of A bar and C in the answer. Then we write the reduced expression as product of B with A bar plus C. This is our final answer. If you want to practice more questions like this, you can visit our website simplycoding.in. Thank you and goodbye.